Around 40 members have joined. So today we start a new topic, that is threaded joints or bolted joints. So far we've seen riveted joints, and then we've seen about how to design welded joints also. So in the beginning we classified the basically joints into two types or two categories. One are permanent joints, the other type is the temporary joints. So your bolted, sorry, not bolted, that riveted joints and welded joints, they come under category of permanent joints. Whereas the threaded joints, of course, in the next after this we have one more topic which is quarter joint. The quarter joints and the threaded joints, these are comes under temporary joints. So what is the difference between the permanent joint and temporary joint? As per the definition, the only difference is hello. ఎవరు క్లాస్లో ఉన్నారా తర్వాత ఫోన్ చేయి. So here, if you want to dismantle or disassemble and assemble the joint, if you want to disassemble and again you want to assemble the joint, if it is possible without destroying the joint, then we'll call it as a temporary joint. If it is not possible without destroying the joint, it is not possible to dismantle it, we call it as a permanent joint. So in case of riveted and welded joints, so if you want to dismantle the connecting plates, then you need to destroy the joint, then only it is possible. So that's why they are permanent joints. Here in case of this bolted joints or threaded joints, generally we use bolts and nuts, so you can easily dismantle or you can easily assemble without destroying the components which are going to be joined. So therefore the threaded joints are termed as temporary joints. Okay, right. So today what we'll do is we'll see some basic terminologies in these threaded joints, and later we'll move to the analysis part of also. Maybe in first two classes we'll discuss about only the whatever maybe the various terminologies used in case of the threads. I think some of you or maybe the most of you familiar with those words, the terminology, because you might have studied your CMDF course, you might have drawn some bolts and nuts, all these things also. Anyway, even though if you have already studied there, just we'll recall what is the terminology we are going to use in case of these threaded joints. Okay, so first the definition for the threaded joint. Threaded joint, you can call it as a bolted joint also. You cannot call it as actually bolted joint. So bolted joint is a narrow definition for a threaded joint. So bolted joint is a form of a threaded joint, but other than bolted joint also you have different threaded joints also. That's why I given the title as threaded joints. Threaded joint is defined as a separable joint. So like already told to you, so this is a temporary joint. That means you can easily separate the connecting components in case of this threaded joint. So threaded joint is defined as a separable joint of two or more machine parts. So the connecting parts may be two or more machine parts that are held together by means of threaded fastening such as bolt and a nut. So if it is a bolt and nut, then we can call it as a threaded joint. Sometimes instead of bolt and nut, you may use the screws, or you may use stud and nut, like that. So maybe anyway, broadly, whatever it may be, that comes under the threaded joint. And this threaded joint is defined as a joint which is connecting two or more parts that are to be held together by means of a threaded fastening. That means, so in the connecting members there should be some threaded member. So that may be a bolt and nut both. Bolt will have threads as well as nut will have threads. So using bolt and nut we are forming a joint. So that's why we'll call it as a threaded joint. Then the salient features of this definition are, so you can see if I expand the definition here, the threaded joints are used to hold two or more machine parts together. These parts can be dismantled if required without any damage to the machine parts or fastening. So therefore, threaded joints are detachable joints unlike welded joints. So that's what I already told in the beginning. So threaded joints can be dismantled without distracting or without breaking down the connecting components. So therefore, these are also called temporary joints. Whereas in case of welded joints, which is not possible. Then thread is a basic element of these joints. So in case of threaded joints, so like I already said by the definition, there should be some threaded component. Then only we'll call it as a threaded joint. So that means a thread is the basic element of these threaded joints. So how the thread is formed? So what is the definition for a thread? A thread is formed by cutting a helical groove on the surface of a cylindrical rod or a cylindrical hole. If it is a cylindrical rod, we'll call it as a bolt. If it is a cylindrical hole, we'll call it as a nut. So that means if you have a external threads, we'll call it as a bolt. If you have an internal thread, we'll call it as a nut. So that is the features of this thread. That is one of the features of this threaded joint. The threaded element can take the shape of bolt or nut, or maybe screw or maybe stud, like already told. Sometimes threads are cut on the parts to be joined also. So in that case, we'll go for the screws. The welding is, sorry, here this point is not there. Maybe it is added here. This related to the welding, and I'll remove that. So here, this is what about the features of these threaded joints. So thread is a basic element of these joints. The thread is formed by cutting a helical groove on the surface of a cylindrical rod or cylindrical hole. Then the threaded element can be take a shape of a bolt or nut. Like I already told to you, if the threads are external threads, means if you cut on a cylindrical rod on the outer surface, we call it as a bolt. If it is a cylindrical, the threads are cut in a cylindrical hole, so that is we'll call it as internal threads. So that we'll call that part, that component, we'll call it as a nut. So again, screw and stud, they're also having a threads on a cylindrical portions only. So we'll see what are these screws and nuts also. Okay, then coming to the advantages. So in the beginning itself, I already told, if you want to dismantle the joint without breaking the components, you can do that. That is the advantage of these threaded joints. Apart from that, what are the other advantages of these threaded joints? So if you look at any practical assembly of a machine components, definitely you can see at least there is one threaded joint in any machine component. So therefore, these threaded joints are extremely used in mechanical assemblies. Wherever you see any machine component or machine element or any machine, so definitely you can see at least there will be one threaded joint in that machine assembly. So that's why these are the threaded joints. These are the most widely used joints in case of mechanical applications or assemblies. It has been observed that over 60% of the parts have threads. So in all these mechanical assemblies, it is observed that there are more than 60% of parts having threads. So that means more than 60% of parts we have threaded joints. So why this extensive use of this threads in mechanical assemblies? What is the reason for that? The popularity of this threaded joint is due to the following advantages. So because these threaded joints have certain advantages, so because of them they are widely or most popularly used joints in case of mechanical assemblies. And the advantages are: 1. The parts are held together by means of a large clamping force. there is not here, there is a wedge action at the threads which increases the clamping force. There is no loosening of the parts, therefore threaded joints are reliable joints. So now if you compare threaded joints with respect to the other type of joints, so if the reliability is the question, or if the reliability of the joint is of most importance, then these threaded joints are going to be more reliable when compared to other joints. The reason for that here is the threaded joints are held together by means of a large clamping force, means the joint is not going to fail that much easily. So the clamping force is provided by the wedging action of these threads. If you want to increase, you can increase the clamping force also. Just by tightening it, you can increase the clamping force. If I have a bolt and nut connection, if I want to increase the clamping force, then what I have to do is, I have to tighten the bolt or nut further. If I tighten more, the clamping force will also more. That means that comes from the wedging action of the threads. So this is one advantage of this threaded joints. The second one is the parts are assembled by means of a spanner. So here the length of the spanner is large compared to with the radius of the thread. So therefore the mechanical advantage is more and force required to tighten the joint is small. So like if you take other joints here, so in case of this permanent joints, if you want to, like I already told, if you want to increase the clamping force, what you need to do is, you need to tighten the nut. So that the tightening of the nut is taking place by means of a spanner. Spanner will have some leverage or length. So because of the, if the length is more when compared to the diameter of the nut or diameter of the bolt, so the mechanical advantage is more. So that means, what is the mechanical advantage? So load applied or load generated at the nut divided by the load applied at the end of the spanner. So if that is the more means, with less amount of force applying to the spanner, you can easily tighten the nut. That means you can apply more force at the joint. So that is the another advantage of these threaded joints. So that means if you want to increase the clamping force, you can easily increase the clamping force. That's what you want to say here in this point. Then coming to the next one, third point. This is going to be the disadvantage. So those are the advantages. These two are the advantages for this threaded joints. Then coming to the disadvantages, definitely there are some disadvantages also there for this threaded joints. What are the disadvantages? The major thing is the stress concentration. So we studied about the stress concentration. We know what is the effect of stress concentration on the commission components also. So therefore, whenever there is a stress concentration, it will make the component weak. So that's what. Why there is a stress concentration in case of threaded joints? Because if you want to make a threaded joint, you need to drill holes. So threaded joints require holes. Why required holes here? In order to insert that bolt into that hole or connecting parts. In order to join the two connecting parts, you need to drill holes in the connecting parts. Then only you can insert the bolt and you can tighten the nut so that the joint can be formed. So these holes will produce the stress concentration. Not only that, so if you take a threaded joint, so like we said, there is a threads are cut on the bolt as well as on the nut. So because of these threads cutted on that portion of the part, so even that is also there is a variation in the geometry. So we know stress concentration, whenever there is a change in the geometric cross section, stress concentration will induce. So now because of these threads also there is a stress concentration. So therefore one thing is because of holes there is a stress concentration. In addition to that, so because of threaded portion in the threads, there is a stress concentration there also. So therefore, these two combining, they are these threaded joints are more vulnerable to the fatigue failure. So of course, in case of static loading, the stress concentration may not be there in case of a ductile materials, whereas in case of fatigue failure, fatigue loading only, this stress concentration will play a vital role. So therefore, if since you have a thin concentration because of threaded portions in the parts as well as the holes, so therefore these threaded joints are more vulnerable to the fatigue failures. So that is one of the disadvantages. And the second one is threaded joints are loosened when they are subjected to vibrations. So now if you take permanent joints, so by the definition they are permanent. They are means they are not going to loosen anything. Whereas in case of these bolted nuts, the bolted joints are maybe the threaded joints. If the joint is subjected to some vibration, obviously this joint will loosen. That means if you have a bolted nut connection, if that particular component is subjected to vibration for certain time, then obviously there is a loosening of the joint. So that will loosening of joint means it will make the joint inefficient. So that is also a disadvantage in case of these threaded joints. Then next, threaded fastener are considered as a major obstacle for efficient assembly. So here, in order to join two components or two members using the threaded fasteners, you are providing or you require additional space to provide the joint. You need to have a space to provide or seating for the nut. So then whenever in our assembly, this nut is going to be obstacle in order to have a efficient assembly. So that's why this is going to be one of the one more disadvantage of this threaded joints. In manual assembly, the cost of tightening a screw can be 6 to 10 times the cost of the screw itself. So therefore, design for manufacture and assembly recommends minimum number of threaded joints. So that means, so if you take any threaded joint, so you cannot choose the number of threaded fastener in the component. So there is, as per this DFMA, that is design for manufacture and assembly, you need to consider a minimum number of threaded fastener in the joint, so that then only it is going to be the efficient one. So therefore, if you are going for more than one joint, then against it is going to be a costly affair. So therefore, that means the cost of the joint is more. So if the cost of joint is more, then that is going to be another disadvantage for these threaded joints. Okay. So right. So far we are saying what is a threaded joint, then what are their advantages and what are their disadvantages. Then comes what are various types of these threaded fastenings, or what are basic types of these threaded fastenings. So they are generally, if you take any threaded fastening, so what are the basic parts in that threaded joint or threaded fastening? You can see there are 3 parts in any bolted joint, maybe sometimes 3, sometimes 2. So they are bolt or screw. So you can't have both bolt and screw at the same in a single joint. In a single joint, either you can have a bolt or a screw. That is one part. Then the second part is nut and the third part is washer. So that means either you can have a bolt, nut and a washer as a part of your joint, parts of your joint, or you can have screw, nut and a washer. So these are the 3 components. Either, so in first case we call it as a, depending upon the, if you use bolt and nut, we'll give one name, that we call it as a through bolt assembly. If screw and nut are there, we call it as a screw joint. So something like that, depending upon the type, whether you are using bolt or screw or stud. So we'll classify the joints accordingly. So therefore, these are the basic components or basic parts for any threaded joint. There is a basic difference between bolt and the screw. So like I already told here, you cannot have both in a single joint. You cannot have bolt and screw in a single joint. So that's why either you can have a bolt and or you can have a screw. So then, if we are using 2 things, means what is the difference between this bolt and screw? So anybody can tell what is the difference between bolt and screw? I think you might have already studied all these things. So we'll do like this interactive session just by reading those slides. So it's not going to be that much effective. So first we'll discuss with you. Then I'll ask some questions. So based on your response, then we can discuss. So what is the difference between bolt and screw? You might have seen that in the slide. I already written that. Maybe if you see that, you can answer it, or else if you know the answer also, you can answer it. Anybody can answer? Your answer there. So if nobody is answering, then what I need to do is I need to pick somebody. So LE4 is saying something. What is that? What is the difference between bolt? Yeah.
Bolt అయితే heavy duty వాడతాం సార్. Screws అయితే light duty వాడతాం సార్.
That is okay. Then I am not asking about whether what type of application they are using. So basically, or geometrically, or maybe if you look at the figure, you can say that, you can say it is going to be bolt or it is a screw. How you can say that? What is the basic difference?
సార్ బోల్ట్ కి అయితే ఎండ్ రౌండ్ ఉంటుంది సార్, స్క్రూ కి అయితే షార్ప్ ఎండ్ ఉంటుంది సార్.
షార్ప్ అంటే ఏంటమ్మా?
అంటే ఎండ్ కి వచ్చేసరికి పిన్ పాయింట్ అయిపోతుంది సార్. బోల్ట్ కి అయితే నార్మల్ గా
ఎండ్కి వచ్చేది థ్రెడెడ్ ఉంటుంది. అంటే సో సిలిండ్రికల్ పోర్షన్ కాస్త కోనికల్ స్పేస్ లాగా వస్తుందా?
కోనికల్ సెక్షన్ వచ్చేస్తుంది.
అన్ని స్క్రూస్ కి అట్లానే ఉంటుందా? అరే డ్రాయింగ్ గీసినట్టు ఉంది కదా, సిఎండిపిలో గీయలేదా మీరు? మనం ఎక్కడ గీసామో ఎవడోవాడు గీసాడు, ఆ గీసిన దాన్ని కాపీ పేస్ట్ చేయడమే కదా. ఈవెన్ ఎగ్జామినేషన్ లో కూడా ఏంటంటే రాయల్ మెక్ ఈమెయిల్ ఐడిని తీయడం దాన్ని పోస్ట్ చేయడం. సో క్వశ్చన్ ఎగ్జామ్ లో ఒకటి గీయండి అంటే వాడు గీసి ఏదో దాంట్లో ఏది గీయాలో తెలకుండా మొత్తం పెట్టాడు దాంట్లో ప్రింట్అవుట్ తీసి. ఇంకేం తెలిసింది మనకి? కాపీ కొట్టడం నేర్చుకుంటే ఇంకా మనం ఎక్కడ నేర్చుకునేది ఏముంది? ఇంకా ప్రతిదానికి మనం కాపీ కొట్టడానికి మన మార్గాలు ఎత్తుకుంటాం, కానీ మనం చదవడం నేర్చుకోవడం ఇట్లాంటి ఏం చేయంగా. సో క్లాస్లో 70 మెంబర్స్ ఉంటే 70 మెంబర్స్ కాపీ ఒకటికన్నా నేర్చుకుందామని ఇంట్రెస్ట్ లేదు. ఇంకేం ఆన్సర్లు వస్తాయి ఇప్పుడు? ఇట్లాంటి ఆన్సర్లే వస్తూ ఉంటాయి. ఇంకా క్వశ్చన్ అడిగితే ఇదే ఉంటాయి, ఈ ఆన్సర్లే వస్తూ ఉంటాయి. So the basic difference between the bolt and the screw. A bolt is a fastener with a head and a straight threaded shank and intended to use with a nut to clamp 2 or more parts. So this is the definition of a bolt. So I think you know now, you might have seen the bolts also. Definitely bolt should have a head. Without head we can't call it as a bolt. So we'll call it as a stud. There is one more thing that we'll call that is also there. We'll discuss that also later. So a bolt will have a head, then straight threaded shank. So what it is? I think I have some picture here. I'll show that also here. Okay, you can see here. Okay, I'll go further. Yeah, you can see it here. This is what I'll call it as a bolt. See, this is the head and this one. So the portion from this location to from this portion, this cylindrical portion, this portion I'll call it as a shank. I'll call it as shank. So then this portion we'll call it as a threaded portion. So this shank portion, entire the shank portion will covered in the whole of the assembly. So like I already told, we need to create a holes in the connecting parts. So this shank portion, whatever maybe the shank portion is there, that is covered in that hole. Only the threaded portion will come out. So on this threaded portion, you will use nut to connect, to assemble the jar, to form the joint. To form the joint, here you will use the nut. Okay. So that is the definition of bolt or description of the bolt. So I'll go back. But the same bolt can be called as a screw when it is threaded into a tapped hole in one of the parts and not into the nut. So that is the difference. See here, the head may be sometimes, okay, maybe that what you can say, the size of the head may be different, but definitely screw will also have some head. But here the connecting member is the member which we are going to connect, not the nut. So that is the difference here. So in case of, if you want to use bolt, definitely in order to form the joint you require a nut. Whereas if you want to use a screw, so that also we call it as a threaded joint. So in order to make the joint, what you have to do is you need to create the threads in the assembling part itself. In the part itself you need to create the threads, and the screw will go and sit into the threaded portion of the part. So then you will have a joint. So that is the difference. That is the only difference. That's why here, in case of screw, you don't have to use the nut. Although bolt and screws are similar, there is a functional difference in their assembly. So what is that functional difference? The bolt is held stationary while the torque is applied to the nut to make the threaded joint. So this already told to you. So if you want to tighten the joint, we won't apply any load or any torque to the bolt. We'll apply it to the nut only. So why you need to apply it to the nut only? So you can replace the nut very easily when compared to the bolt. Or the cost of the nut is cost of the nut is less when compared to the cost of the bolt. So if you tighten it more, if the joint will fail. So that means bolt will fail. Instead of bolt will fail, only the nut will fail. If the nut will fail, you can easily replace that. So because its cost is less. So that is what you are doing in case of a bolted joint or bolt. You will keep the bolt as stationary and will apply the torque to the nut. Whereas in case of screw joint, so that means instead of bolt, if you are using screw, you need to apply the torque to the screw itself. You need to apply the torque to the screw itself. So that means in case of your bolted joint, bolt is not subjected to any load. Of course, it is subjected to load, but it is very, very less. Whereas directly in case of screw, directly you are applying the torque. So therefore, screw will take more load when compared to the bolt. So that's what written here. Although bolt and screw are similar, there is a fundamental difference in their assembly. A bolt is held stationary while torque is applied to the nut to make the threaded joint, whereas torque is applied to the screw to turn it into the matching threads in one of the assembling parts. So that is the difference. Then this is the definition for a nut. A nut is a small symmetrical part, usually having hexagonal or square shape and containing matching internal threads. So already told, nut will have internal threads. So that too matching. What is the meaning of matching internal threads? So here the diameter, the nominal diameter of these threads should be equal to the nominal diameter of the bolt. Then only the joint can be formed. Otherwise, it is not formed. So that's why here I said it is containing matching internal threads. Matching internal threads means the nominal diameter of this internal thread should be equal to the nominal diameter of the bolt. Then we have washer. So what is the washer? Washers are thin, annular shaped metallic discs. Generally, these washers are in the form of a disc, but the thickness of the disc is very small. So that's why they are thin, annular. Why it should be annular? Because it needs to be inserted into the bolt. So it is a hollow circular cross section. So that's why they call it as annular shaped metallic discs. So why we need to use washer? In case of even without using washer also, you can make a bolted connection or you can make a threaded connection. But still some applications still washers are used. Why washers are used and what are the functions of this washer? These are the things here. If you use washer, it will distribute the load over the large area on the surface of the clamped parts. So that means, so generally the diameter of the washer is more than the diameter of the nut. So therefore, the area which is in contact with the part and with the washer is more when compared to the area which is in contact with if you use only nut. So nut since the nut diameter is smaller than the diameter of washer, so therefore the area is less. If you use instead of washer, if you use directly nut, so the contact area is less. If the contact area is less, then what happens is your contact stress is going to be more. Your stress is nothing but load by area. For the same load, if the surface area is more, the stress is going to be less. If it is less, it is going to be more. So that means if you use washer, what it is doing is, so distribution of load in the sense, it will decrease the magnitude of the stress. That is the meaning of that statement. It distributes the load over the large area. So that means load per area. Distribution of load over a large area means load by area is small. That means the stress is small on the surface of the clamped parts. Then the second purpose is it prevents marring of clamped parts during the assembly. So that is the second function. Then third one is it prevents marring of the bolt head and nut surface during the assembly. So for this purpose, the washers are used in these threaded joints. And also not only that, it provides bearing surface over large clearance walls. So that is also like already told, if you use washer, it will increase the contact area. So contact area increases means what happens is the bearing surface is going to be increased. So because of that, you have a less bearing stress. Okay, so those are the only basic elements of your threaded joint. So then next comes what are different types of we not yet come to that one. So here in this picture I showed what are different types of threaded joints. So in that you can see that threaded fastenings are classified according to their shape and purpose for which they are used. Here the classification is based on shape and also on what purpose they are using. Based on that they are classified. You can see that here in this picture you have three types of joints. All these three are threaded joints only. But first one we'll call it as a through bolt, and second one we'll call it as a tab bolt, and third one we'll call it as a stud. So what is the difference here? You can observe from these three figures here. In case of first joint, you can see you have a bolt and the joint is formed by a nut here. Joint is formed to a nut here. So only the shank portion of the nut bolt is inside the hole, and this is one connecting member and this is the other connecting member. So this is the bolt head. So if this type of connection is there, we call that one as a through bolt connection. Then coming to the second one, so this is one part and this is another part. So we need to join these two parts. So here the hole is not there throughout in this. If you see in the bottom part, the hole is not throughout. So but here the hole is only from this point to this point only. But here in that hole again you need to create the threads so that the joint can be formed here. So that means this part itself will behave as a nut. Here for the assembly we are using nut separately. Whereas in this case, in case of this tab bolt, whatever you can call it as tab bolt, that means only you have a bolt, you don't have a nut. But in order to create the joint here, so the second member which we are going to join will have a threaded portion in itself. So therefore this will be then once you insert this thread into this, so therefore these two will form a joint. So this type of joint we call it as a tab bolt. So why we will call it as a tab means, so you can see you have a tab screws also there. So this is tab bolt. The only difference here is here you have a, in case of bolt, definitely you should have a shank portion, and then you should have a threaded portion. So, and also in addition to that, you should have a head also, something like hexagonal or square head is there in case of a bolt. So, this kind of connection we'll call it as a tab bolt. Then the third one is going to be a stud here. The third one is stud. So, what is the difference between this one and this one? So, if you look at these pictures carefully, so in this case and in this case you have a head to the bolt. So, but here in case of stud you don't have any head here. You don't have head here. So, this head is not there. But it is a threaded portion and the threads are cut on either side. So, this side, left side is, this side there are threads, even this side also there are threads. So, this threaded portion is inserted into the part which you are going to connect it, and other side here will use washer and nut to form the joint for this member. So, here this member is joined to this stud through the threads here. So, this is connected. Then to connect this point, this part to this part, we need to use here washer and nut, so that this joint can be formed here. So, this type of joint we call it as a studded joint. Okay. So, basically you have these three different kinds of joints in case of these threaded joints. There are screw bolts, tab bolts, or cap screws, like already told. So, if this one is replaced by a cap screw, we can call it as a cap screw connection. The same thing. The difference is, only thing is, the bolt is the difference between bolt and screw only. So, it's the bolt here, we'll use the screw. So, that's it. So, that is, we can call it as either tab bolt or a cap screw. Then the third one is going to be the stud. So, now, once you understand this, next we'll see in which application what type of joint you are going to use. So, when in what situation you will use this screw bolt connection, in what situation you will use this tab bolt or cap screw connection, and in what situation you are going for this stud connection. So, that we'll see in the next slide. Screw bolts are used under these following conditions. The first condition is the parts that are fashioned have medium thickness. Example, plates, flanges or beams, and space is available to accommodate the bolt head and the nut. Space should also be available to accommodate the spanner to tighten the nut. So, if these conditions are satisfied, then you can go for a screw bolt connection. So, that means the important point, what is the important point here is, there should be space available for the accommodation of bolt head and nut. That is important thing. If you in the assembly, sometimes you may not have a space to accommodate this bolt head and nut, then you cannot use this screw bolt. So, if that space is available, then only you can go for it. And also, not only that, the space should also be available to accommodate the spanner to tighten the nut. So, in order to form the joint, you need to tighten the nut. So, to tighten the nut, you should have some space, or the space should be there in order to, so that you can tighten the nut. So, for that, if even the space is not available, even though if you place a bolt and nut, the space is available to locate the bolt and nut, but there is no space available to tighten the nut, still you cannot form the joint. So, therefore, these two should be the major considerations when you are going for a screw bolts. So, not only that, only thing, these are used in case of a medium thickness plates. So, when you have a plate having medium thickness, why it is medium thickness? If there is a less thickness plates are there, then what happens? If you use for screw bolts, in case of less thickness plates, if you go for screw bolts, what it will do is, so in order to use screw bolts, you need to drill the hole in the plate. So, if the thickness of the plate is very small, then if you drill a hole in that, so it will make the plate much more weaker. So, that's why in case of lesser thickness plates, we won't use screw bolts. We'll go for cap screws or studs. We'll go for. So, not for we want to use screw bolts. So, this is the one constraint or one condition where you can use screw bolts. Then the parts that are fashioned or made of materials which are too big to make durable threads. So that means, see here we are connecting two members. So if I want to use set screws or maybe cap screws or tab bolt. So if I want to use that, then what I have to do is, in the parts itself I need to create a threads. But so the material of that the connecting part is such that it is not able to, or it is not possible to make threads in the parts because of its weakness. So in such situation there is no other go. So that means you cannot use the tab bolt or you cannot use the stud. Then only available option is going to be the through bolt. So in that case, so that means the parts that are fashioned made of materials which are too weak to make durable threads. So that means even though if it is possible to make the threads, but if the threads are worn out very easily because of their weak strength, if they are worn out easily, so then your joint is going to fail very quickly. So in that case also we are not going for, we'll go for these screw bolts instead of going for the tap screws or maybe studded joints. Thus through bolts connections are used in that condition also. Then the parts that are fashioned require frequent dismantling and assembly. So if that kind of application is also there, we go for these through bolts. So frequently, if it is required to dismantle and assemble, disassemble and reassemble. In such situation, so this is the easiest way of doing it. So if you go for other two joints, then if you are rotating the thread, if you are dismantling the joint and reassembling the joint, so there may be some worn out edges are there in the assembling part which will weaken your joint. So therefore, we won't go for stud and tap screws when there is a frequent dismantling and reassembly is there. In that situation, we go for only through bolts. So then, depending upon the usage, these through bolts are also named as machine bolts, automobile bolts, eye bolts, or carriage bolts. So depending upon the application, how you are using these through bolts, they are again given some other names. So they may call it as a machine bolts, automobile bolts, or eye bolts. I think we might have drawn these things, some sort of eye bolt in our CMDB course. Eye bolts are carriage bolts. So these are the names given based on their application of this through bolt. So like this, you can see under what conditions you are going for these are the conditions under which a through bolts can be used. Okay. Maybe now it is 4 o'clock. I think we have up to 4:15. Na? Okay, right. So we will continue for 15 more minutes. Then we will close it. Then next category is tab bolts or cap screws. So under what conditions these tab bolts or cap screws are used? Tab bolts or cap screws are used under the following 3 conditions. What are those 3 conditions? One of the parts is thick enough to accommodate threaded hole. So, like already told in case of through bolts, so if the part is very thin, then you cannot create a threaded hole in that part. So, because the threaded hole, if you create threaded hole in a thin part, it will make the part is weaker. So that means your joint is going to fail easily. So therefore, whenever there is a thick enough plates are there or thick enough parts are there which are capable of accommodating the threaded hole, then we can go for these tab bolts or cap screws. Then the material of the part with threaded hole has sufficient strength to ensure durable threads. So that means with the material which we are using for the threading, so that material is weak, then your threads are worn out very easily, like I told in the previous case. That means whatever conditions you are choosing for the through bolt, so if they are opposite, then only you can go for the tab bolt. You can see that the first 2 conditions are what you see in the through bolt, they are here, they are now in opposite. So there we are going for the thin plates. Now these are used for the thick plates. There we are not using the through bolts when the parts are weak, or if the threaded hole has not sufficient strength to ensure the durability of the threads, we go for the tap bolts. We go for the through bolts. But here, if the material has having sufficient strength to ensure a durable threads, then we go for these tap bolts. So then finally the third one is there is no place to accommodate a nut. So if there is no place to accommodate a nut, then definitely you need to go for tap bolts only. So quite opposite. These three conditions are quite opposite to the previous three conditions. If you look at the previous three conditions for the through bolts, so there should be sufficient space to accommodate bolt head as well as nut, and also not only that, it should have sufficient space should be available for spanner in order to tighten the nut. So that is the first condition what we have seen in case of through bolt. Here it is opposite. If there is no place to accommodate nut itself, then we go for the tap bolts. Similarly, the remaining two also quite opposite what we discussed in case of the through bolts. Okay, so under these three conditions, we can go for either tap bolts or cap screws. Then the last one is stud joints. So under what conditions these stud joints are going to be used? The first one is one of the part is thick enough to accommodate a threaded hole. So here we are not using any nut. Even in case of studded also, one part is going inside the connecting part only. So the threaded joint is created with the connecting part itself. So that means at least you should have one part which is thick enough to accommodate the threaded hole. If not both, if both are enough, so then we will go for again we go for the threaded joint, that is studded joint only. So but at least one part should be thick enough to accommodate the threaded hole. Then the material of the part is with the threaded hole has sufficient strength to ensure the durable threads. So these two conditions are satisfied. So for the given part, then we can use that part as a nut itself. If our connecting part is having sufficient thickness to accommodate this threaded hole, and also the strength of the threaded portion is going to be sufficient enough in order to ensure a durable threads, then obviously the connecting component will become a nut itself. So under these conditions, we can go for the threaded joint, a studded joint, and the final one is the material of the other part. So that means these two conditions are corresponding to the one connecting number. So coming to the other one, the second part. So that is the other part. So the material of the other part without tapped hole cannot ensure sufficient durability of the threads. Example, light alloy or cast iron. So that means in the second part, it is that means the properties of the second part is quite opposite to the properties of this first part. So in case of the first part, it is thick enough to accommodate the threaded holes, and not only that, it has a sufficient strength to ensure the durability of the threads. So then you can create the threads in the part itself. Whereas in the second part, if the second part is having a properties which are opposite to this, that means if you are able to, one thing is it is not possible to accommodate a threaded hole, that is one case, or even if it is possible, so your threads are not having sufficient strength to ensure a durable life of the threads. So then in that case, I am not going to create a thread in the part itself. So I use nut and washer to connect the parts. So therefore, under these three conditions, the studded connection or studded joints are used. The parts that are connected to required frequent dismantling and reassembling again. So this is also, in this case also, if this condition is there, so that means if you want to frequently disassemble and reassemble the connection parts, again we can go for this studded joints. So only thing is when first one and the last one we can use whenever there is a frequently disassemble and assemble. So then in that case either you are going for the studded joint or through bolt joint. So what is the reason for that? because you are using a nut there. So you can easily tighten the nut, or you can easily loosen the nut, or you can remove the assembly. So whereas in case of cap screws, you cannot use frequent assembly and disassembly in case of a cap screw or tap bolt joints. So these are the different types of screw fastenings, and under which conditions we are going to use those three types of threaded joints. So studs are particularly used for connecting cylinder with the cylinder head. If you take our IC engines, or maybe whenever there is a cylinder and cylinder head, to connect that, so generally these studs are used. So that means for a stud you have both sides. So that means both ends will have a threads here. Whereas in case of bolt you have only one end, threads are there on one end. Whereas in case of even tap bolt also you have threads on only one end. So whereas stud will have threads on either side. So both ends there are threads are there in the stud. So that means if you want to connect the two parts through the studs, if those two parts are having internal threads in themselves, so then you can directly join them using the studs also. Or else, if one part is having the internal threads, then the other part can be joined through a nut and washer. So in case of the cylindrical head and cylinder, so both will have internal threads in those two parts. In the cylindrical head there are internal threads. Even in the cylinder also there are cylinder also there are internal threads. So using those internal threads without using nut and washer directly, these two are connected by using the studs. Okay, so that is about these basic types of joints. Then we have a topic which is called bolt of uniform strength. So what is the meaning of this bolt of uniform strength? So far, okay, I'll show that here. Yeah, you see that here, you have a bolt. So this bolt doesn't have a uniform strength. Meaning, what is the meaning of that statement? I'm saying that this bolt is not having uniform strength. Why it is not having uniform strength? If you look at the diameter here, diameter of the bolt, so this shank portion diameter is D, whereas this threaded portion diameter is also D. But because you are cutting the threads here, the core diameter or root diameter of this thread is going to be, we'll take that one as some DC, core diameter or root diameter. This DC is smaller than this D. So that means here the diameter is smaller. So because of this, what you can say that here the diameter is small means there is a change in the cross section here. So because of that you have a stress concentration. So whenever there is a stress concentration is there, we can't say the stress is uniform. So that means at a certain locations or certain concentrated locations, the stress is going to be more. So that means here stress is more means the strength is not uniform. So that means at this point you have one stress, at this point you have another stress for the same load application. That means it is not having uniform strength. So how I can make a bolt which is having a uniform strength? That is the next question. Maybe we'll discuss these things in the next class. Coming maybe in the next class. Not maybe okay. Today is Wednesday. Maybe Thursday. I think we have one more. We have class tomorrow also. We'll see in the tomorrow's class. So I'll stop the discussion at this point. Maybe I think next class is also ours only, DMM only, right? So what we'll do is I would like to conduct some discussion class. So about your doubts in the next half an hour or maybe 45 minutes, whatever time you want, up to 1 hour, we want to discuss your doubts. So that introduction to that voltage giants, now I'll stop temporarily. I stop at that point. So now I want you to ask some doubts in the course so far, whatever we discussed. Not anyway, today's class it is only theoretical part. There won't be any doubts in that. In the previous problems, whatever you want, you can ask your doubts. So we'll conduct doubts clarification session for the next 1 hour. So if you ask your doubt, you can ask. If you have any doubt, you can ask regarding any topic so far what we discussed. Now it need not be only welded joints or riveted joints, whatever you want, you can wherever you want, you can ask. If you don't have any doubt now, then what I'll do is I'll give one question and I'll ask you try to solve that problem, and then you need to upload that into your classroom so that you will get the attendance. I think you are not going to ask any doubt. Maybe that is clear. Then what I'll do is I'll give you one problem to you. So anyway, so I'll open that. So you need to solve that problem and you need to upload that one in the classroom, so that then only you will get the attendance for both the classes, not only first class, but both the classes you will get the attendance. Okay, what I'll do is go for the machine design books. Okay. Maybe what I'll do is first I will stop the recording of this class because we are not discussing anything here. I'll stop.